So unit 12, integration with respect to abstract measure. Okay. With respect to abstract measure. So introduction. Let us recall that the measurable functions phi and a measurable space x a mu is said to be simple if it assumes a finite number of values only. We first define the integral of such simple functions with respect to a complete measure mu. Based on this, we define the integral concepts. Concepts. Further, a method of definition uh, integral with respect to complete measure to that with respect to a general measure is also detailed in the unit. Uh, in the sequel, x a mu stands for a complete measure space unless otherwise mentioned, that is measure mu of the following property. A belongs to capital A. Measure A equal to 0. Here A belongs to script A. A belongs to script A. A belongs to script A. That equal mu of A equal to 0. Mu of A equal to 0. Mu of A equal to 0. And B subset A. B is subset A. B is subset A. That equal to B belongs to A. That implies B belongs to script A. B belongs to script A. B belongs to script A. So, integral of simple functions. Integral of simple functions. So recall that measurable function phi and a measurable space x comma a, taking finite number of distinct values is called simple functions. So phi, a measurable function phi and a measurable space, uh, measurable function phi and a measurable space, simple functions, integral of simple functions, integral of integral of simple functions, integral of simple functions. FNS means functions. Integral of simple functions. Integral of simple functions. A measurable function pi, a measurable function pi, measurable function pi. So a measurable function here pi, a measurable function pi, and a measurable space. Measurable space. Measurable space. x comma a comma script a x comma a script a. Taking finite number of distinct values, okay, finite number of distinct values distinct values is called a simple function. It's called a simple function. Called a simple function. A1, A2, An are the distinct values. A1, comma, A2, etc. An. A1, A2, etc. An are distinct values taken by the measurable functions. Distinct values taken by the distinct values taken by the measurable functions by measurable function y on x, comma y. Y on x, comma script a, x, comma script a. So definition. Suppose E is a measurable set by, suppose E is measurable set measurable set, measurable set, and the pi is non-negative simple function, and pi is non-negative simple function, non-negative simple function, given by asterisk or star. We define the integral of pi. We define the integral of pi. Integral of pi with respect to mu. With respect to mu. With respect to mu. Denoted by pi d mu. Denoted by pi d mu. That equal to I equal to 1 to n to n. AI, AI, AI intersection E. AI intersection E. So we immediately have the following theorem. Then based upon this, one theorem will discuss. What is the So what is the definition? Once again, we'll revise. Yes, suppose E is a measurable set and pi is a non-negative simple function. Fn means function given by asterisk. We denote the integral. We define the integral. We define the integral pi with respect to mu denoted by integration e pi d mu that equal to I equal to 1 to n ai intersection ai intersection ai intersection e. So theorem based upon this concept, then theorem will discuss. Most important theorem for 10 marks. If alpha and b are non-negative numbers, and beta are non-negative numbers, non-negative numbers, non-negative numbers, beta are non-negative numbers. Phi and psi are simple function. Phi and psi are simple functions. FNS means simple functions. Pi and psi are simple functions. Then integration and E, integration E, alpha pi plus beta psi d mu, d mu, that equal to alpha outside integration E phi d mu plus beta outside integration E psi d mu. Proof. Proof of theorem. Suppose f taken different values. Suppose SP means suppose f taken means function different values, different values. F taken different values. A1 comma A2 etc. AN on A1 comma A2 comma etc. AN. And side takes the distinct values. Side takes the distinct values. Distinct values. Takes the distinct values. B1 comma B2 etc. B1 R B1 comma B2 and Bm respectively. Bm respectively. Respectively. So phi of x equal phi of x equal phi of x phi of x equal to sigma equal to 1 to n ai x a sigma equal to 1 to n ai x a1 x a1 a1 x phi of phi of x equal psi of x equal sigma j equal to 1 to n j equal to 1 to n AJ, BJ, X, BJ, X, BJ, X, BJ, X, X, BJ, X, BJ. So for all X, then alpha pi, beta psi for all X, X, alpha pi and beta psi, alpha pi and alpha pi, alpha pi plus beta psi, beta psi, beta psi. Takes the values, takes the values, takes the values. Values. Alpha pi plus beta bj, beta bj means I lies between 1 to n. No? J lies between 1 to m. 1 to m. Okay. Eij equal to ai intersection bj or eij ij equal to ai intersection bj, ai intersection bj, ai intersection bj, and hence alpha pi plus beta psi, alpha pi plus beta psi of x equal to sigma I equal to 1 to n, sigma j equal to 1 to m, j equal to 1 to m, alpha ai plus beta bj, beta bj, x eij x, x eij of x. Therefore, integration alpha pi, therefore integration alpha pi plus beta, beta psi, beta psi, d mu, d mu, d mu, that equal to sigma I equal to 1 to n, sigma j equal to 1 to m, 1 to m, 1 to m, alpha ai, alpha ai plus beta bj, bj, ai intersection bj, d mu, d mu, ai intersection bj, ai intersection bj, ai intersection bj, ai, aij intersection e, aij intersection e. Alpha sigma I equal to 1 to n, equal to 1 to n, sigma j equal to 1 to m, 1 to m, ai mu, ai mu, ai mu, ai mu, eij intersection e, eij intersection e plus beta sigma I equal to 1 to n, sigma j equal to 1 to m, j equal to 1 to mu, ej, eij intersection e, eij intersection e, equation number one. Equation number one. So now j equal to union j equal to 1 to m, j equal to 1 to m, union j equal to 1 to m, eij intersection e, eij intersection e, union J equal to 1 to M, 1 to M. AI intersection BJ intersection AI intersection BJ intersection E, BJ intersection E. That equal to AI intersection AI intersection E intersection intersection union of union J equal to 1 to M, union J equal to 1 to M BJ BJ BJ. That equal to AI intersection AI intersection intersection E intersection intersection X intersection X. That equal to AI intersection AI intersection E intersection X E intersection X E intersection X. That equal to AI intersection E intersection E intersection E and EJ intersection A intersection E intersection IK intersection E JK intersection E is null set. JK intersection E equal to null set means empty set. For J is not equal to from J is not equal to K. So that implies mu of AI intersection E. That implies mu of AI intersection E AI intersection E that equal to sigma J equal to 1 to N J equal to 1 to N mu EIJ EIJ intersection EI intersection EI intersection EI by countable additivity of mu by countable additivity countable additivity of mu countable additivity of mu countable additivity of mu. Therefore, first term on the RHS of 1. Therefore, the first term of RHS of 1 formed the first term RHS of equation number 1. Equation number 1 of, of equation number 1. Equation number 1. Equation number 1. Alpha sigma equal to 1 to n. Sigma equal to 1 to n. Alpha I sigma j equal to 1 to n into m. Mu Eij intersection E that equal to alpha sigma I equal to 1 to n. 1 to n. It was not good. 1 lakhs equal to 1 to n. Equal to 1 to n. Alpha I mu alpha I mu of ai intersection E mu of ai intersection E that equal to alpha intersection D mu. Similarly, we can show that the second term of the right of 1. Similarly, we can show that similarly second term of 1 alpha intersection E 5 D mu. Hence the theorem. This completes the proof. Hence proved. Okay. Next. Integral of non-negative measurable functions. Definition. Integral of non-negative measurable functions. Definition. Definition. Suppose f is a non-negative extended real valued measurable function. Suppose, SP means suppose f is a non-negative, non-negative real valued measurable function, real valued, real valued, real valued measurable function, measurable function. Fn means function. On the measure space, on the measurable space, on the measure space, that space, on the measure space, xa mu, xa, xa mu, and E belongs to script A, belongs to script A. E belongs to script A. The integral f with respect to mu, integral f with respect to mu, with respect to mu, with respect to mu, denoted by f d mu, f d mu, f d mu is defined as the supremum of integrals, is defined as supremum of integral supremum of integral supremum of integral supremum of integral e pi d mu equation e pi d mu d mu, where pi ranges over all simple functions, where pi ranges over ranges over all simple functions is satisfying. Satisfying. Pi lies 0 less than 0 less than or equal to pi less than or equal to f. That is integration E of d mu that equal to supremum of 0 less than or equal to pi less than or equal to f integration E pi d mu. Before establish some elementary properties such as the linearity properties, we prove the satisfying Fato's lemma. Most important theorem, Fato's lemma. Fato's Fato's lemma. Fato's lemma. Let Fn be a sequence of state and proof Fato's lemma. Question formation is state and proof Fato's lemma or prove that they will give statement. Let let Fn be a sequence of can be a sequence of non-negative measurable functions so measurable functions non-negative measurable function. FNS means non-negative measurable functions converging to F almost everywhere, converging to F almost everywhere, almost everywhere, almost everywhere on measurable set E on measurable measurable set E on measurable set E. On measurable set E. On measurable set E. Then integration F d mu limit n tends to infinity, infimum integration E f and d mu and d mu. Proof. We may assume without loss of generality. We may assume without loss of generality. WLG means without loss of generality, that Fnx converges to Fx. That Fnx CGS means converges to f of x. F of x. For each x belongs to U. X belongs to U. Also, in view of definition 2, it is enough to prove that each simple function, by definition, it is enough to prove that enough to prove that each simple function pi each simple function pi with means pi lies between 0 and f. 0 and f. The inequality equality inequality integration v pi d psi is less than or equal to limit n tends to infinity, n tends to infinity, infimum of integration e fn d mu in force. Question about force. So, case one. If suppose phi d mu equal to infinity. So phi d mu equal to infinity. Then by definition one, at least one value, say a one, at least one value, say a taken by pi is positive, positive, and the corresponding set a equal to corresponding corresponding set x belongs to capital X, such that pi of x equal to a, such that b of a equal to infinity. If a and intersection k equal to 1 to infinity, n to infinity, x belongs to E such that x belongs to f of kx greater than a, f of kx greater than a, all n equal to. An is a sequence of measurable sets. A sequence of measurable sets. Measurable sets. Sequence of measurable sets. An subset An plus 1. So An belongs to script A. A such that An such that An subset An plus 1. Therefore, if it tends to infinity, mu of a, yeah, that equal to union n equal to 1 to infinity a n, equation number 2, right? But since pi is less than or equal to, than or equal to pi, limit n tends to infinity fn, fn, we get a subset, a subset, a subset, union n equal to 1 to infinity a n. In fact, x belongs to a. Fact, x belongs to a. X belongs to a. Lim tends to infinity. Limit n tends to infinity. Fn x, fn x greater than or equal to pi of x. To pi of x greater than a. Given fn x greater than a, fn x greater than a. For all n greater than or equal to n, where a naught is some integer, x belongs to a n naught, a n naught. They're showing x belongs to, so x belongs to union n equal to 1 to infinity, 1 to infinity, a n. Therefore, mu of a is less than, therefore, mu of a is less than or equal to mu of union n equal to 1 to infinity, a n, a n, a n, a n, which gives infinity, which gives infinity. Hence, by 2, lim tends to mu a n is infinity by equation number 2. Limit n tends to infinity, n tends to infinity, mu of a n, mu of a n that equal to. Therefore, mu of A is, since f and d mu, since f and d mu, and d mu is greater than or equal to integration a n f and d mu, a n f and d mu, that equal to mu into mu of a n. So, a n. We get limit n tends to infinity. We get we get limit n tends to infinity. Infimum of infimum integration e fn d mu d mu greater than a limit n tends to infinity. Mu of a n. Mu of a n. That equal to infinity. So that limit n tends to infinity. Limit n tends to infinity. F and d mu equal to infimum of fn d mu equal to infinity. Give me infinity. Therefore, phi d mu equal to, therefore phi d mu equal to integration phi d mu equal to limit n tends to infinity. Infimum of infimum of integration e f and d mu. In this case, case 2, case 2. Case 2. Case 2. Suppose phi d mu less than infinity. This means suppose integration mu phi d mu less than infinity. If a equals x such that phi of x greater than 0 means positive, then mu of a less than infinity. Mu of a less than infinity. In this case, mu equal to in this case m equal to maximum of phi of x phi of x belongs to E for any epsilon greater than 0. So epsilon, right? Epsilon dash equal to epsilon divided by m plus integration E phi d mu mu a n equal to a n equal to union of a equal to n to infinity. X belongs to A. X belongs to A. Such that fkx greater than fkx greater than fkx greater than 1 minus epsilon dash 1 minus epsilon dash then equal to 1 to infinity. Then n equal to 1 to so on. Then an is a sequence of sequence of an is a sequence of an is such that an bar equal is superset of an bar is superset of an plus 1 an. So that so that limit m tends to infinity tends to infinity. Mu of an bar That equal to V of intersection n equal to 1 to infinity a n bar that equal to mu of pi that equal to pi means not set. So hence each epsilon greater than 0 natural number n naught mu n mu a n bar less than epsilon dash for all n is greater than or equal to n naught. Yeah. N naught is a natural number. Now for n is greater than or equal to n naught, intersection E Fn d mu greater than or equal to integration Fn d mu is greater than 1 minus epsilon dash integration pi d mu is greater than 1 minus epsilon dash integration pi d mu minus integration an pi d mu is greater than or equal to pi d mu integration pi d mu minus epsilon dash integration pi by d mu plus m m means maximum. Thus, integration Fn d mu greater than integration pi d mu minus epsilon for all n is greater than or equal to n naught. So in limit n tends to infinity, infimum integration Fn d mu is greater than or equal to integration pi d mu, proving one in this case. This completes the proof, hence proved. Okay. Theorem number 0, 3, 4, 5, 4 marks. Short answer type most important. Short answer question 4 and 5 is also homework. Do it home. Right? Important. So today I'm leaving. I'll meet next class. Thank you very much.